The era of small, expandable robots is officially over. Lightweight, exploratory probes are merely a diagnostic scan. True survival on another planet requires a brutal transition from a small-scale scouting to massive weightlifting. Welcome to Phase 2. Between the years 2029 and 2033, the operational timeline shifts into an aggressive multivariable logistics. NASA is no longer sending disconnected science experiments. They are systematically constructing an extraterrestrial industrial grid. Look at the raw data matrix. The mandate requires an uncompromising surge. 27 heavy lift launches, 24 automated landings, and the simultaneous deployment of 7 advanced armored rovers. Why are they suddenly dropping 60,000 kg of heavy steel onto the most unforgiving terrain in the solar system? Because to survive, you need roads, megawatt power grids, and deep space cell towers. To understand how NASA plans to execute this massive mechanical overhaul, we didn't just read the press release, we analyzed the raw payload capacities of the commercial lander frameworks, dissected JAXA's heavy rover thermal limits, and evaluated the absolute non-negotiable bottlenecks of operating in razor-sharp lunar dust. This is the exact blueprint for humanity's heavy infrastructure deployment. If a rover moves a few kilometers outside of its narrow tracking loop right now or enters a permanently shadowed crater, its thermal core drops to critical levels. Its communications choke and the machine dies in total isolation. How do you permanently break that logistical blockade? You stop relying on isolated biological islands. You build an integrated municipal grid. You cannot build a functioning lunar colony by continually dragging every single drop of power and every piece of structural support out of Earth's gravity well. Phase 2 solves this vulnerability by demanding heavy, localized utility nodes directly on the ground. To feed an expanding industrial outpost, the state system must completely force open the payload capabilities of its commercial rocket providers. The architecture dictates an immediate escalation. The new rule is a strict, mandatory 5 metric ton structural ceiling for individual landers. Let's translate that weight. 5 metric tons is roughly the weight of a fully grown African elephant. NASA is demanding the capability to drop that exact weight precisely and safely onto an airless jagged surface over and over. This massive leap turns space travel from a low-frequency gamble into a routine, high-volume cargo supply chain. Every individual touchdown must systematically deliver standard utility units. We are talking about heavy site preparation tractors and excavation rovers. Their only job to actively bulldoze, clear out landing pads, and compact the loose, highly abrasive regolith before human crews ever arrive. Phase 2 isn't about exploration, it's a brute force construction project to pave the way for human survival. But once the landing pads are cleared, how do humans actually travel across a landscape covered in microscopic razor-sharp glass? The mechanical centerpiece of this era is an unprecedented international partnership. Enter the Japanese Aerospace Exploration Agency, or JAXA, and their collaboration with Toyota. You would expect a lunar exploration vehicle to look like an oversized, delicate golf cart. The reality is that this machine is a 15,000 kg armored tactical land cruiser. It boasts the total mass of a commercial school bus, paired with the ability to carry an additional 3,000 kg of raw cargo. This vehicle is built to meet an unyielding 10-year lifespan. It supports 2 crew members inside a completely automated, perfectly pressurized environment, allowing them to live and work in standard clothing while surrounded by a deadly vacuum. Think of this pressurized rover not as a car, but as a heavy-duty overland nuclear submarine. It is designed to crawl across a dry sea of razor-sharp volcanic shards. Imagine driving a multi-room, multi-ton mobile laboratory over steep, boulder-strewn crater walls. It can traverse extreme 15-degree slopes. Its automated life support systems constantly maintain perfect atmospheric equilibrium, all while running on rugged, mechanical wheels engineered to withstand thousands of hours of grinding friction. And the environment is actively trying to kill it. Lunar dust is not like dust on Earth. It is jagged, uneroded, and highly abrasive. It shreds standard spacesuits and seizes up mechanical gears. Furthermore, the machine's internal thermal management algorithm is explicitly programmed to survive up to 150 continuous hours in absolute freezing shadow. This ensures the crew can plunge deep into the darkest, most dangerous craters on the moon without experiencing immediate catastrophic freezing of their powertrain. It is the ultimate survival fortress. A 15-ton mobile fortress requires a massive, constant flow of power. So how do you refuel an overland submarine on a planet with no gas stations and 2-week long nights? To continuously juice these massive mobile platforms, the base camp cannot rely on standard low-efficiency batteries. Phase 2 marks the official deployment of a true extraterrestrial power grid. We are talking about massive solar power augmentation systems. These high-mast solar stations tower over the landscape, engineered to capture over 10 kilowatts of electrical energy while the sun is up. But they also cache an extensive 360 kilowatt hours of emergency backup storage, enough energy to power dozens of standard homes, ready to bleed out power during the deep shadow phases. But solar isn't enough. The facility is dropping heavy nuclear surface power infrastructure directly onto the ground. They are utilizing RTG, radioisotope thermal generators, like dropping small, permanently burning atomic furnaces into the frozen dirt, ensuring that no matter how cold the environment gets, the grid survives the night. But generating power is only half the battle. How do you get that power into the vehicles? NASA is introducing wireless charging stations and specialized autonomous rovers designed to snake heavy electrical cables across kilometers of airless terrain. Why wireless though? Because lunar dust treats advanced electrical machinery with the same respect as a paper shredder treats fine print. Dust-tolerant electrical connectors and wireless charging aren't just convenient upgrades, they are an absolute non-negotiable bottleneck to prevent the entire multi-billion-dollar grid from short-circuiting into oblivion. You have the roads, you have the armored transport, and you have the power grids. But what happens if this entire multi-billion-dollar system can't talk to itself? The final utility layer of Phase 2 is the most critical, the surface communications and navigations network. Right now, if a rover wants to send data, it has to burn massive amounts of power, attempting to punch a signal straight back to the orbiting satellites or deep space arrays on Earth. It is highly inefficient and dangerous. Phase 2 fixes this by dropping dedicated surface-to-orbital communication stations. In simple terms, NASA is building permanent cell towers on the moon. These deployable towers instantly integrate and aggregate the telemetry feeds of all local assets. They broadcast navigation signals and direct asset-to-asset communications across a reliable 10-kilometer operational range. You would expect automated charging and communication loops to be a simple process, but managing flawless simultaneous data syncs across multiple rovers in a hostile environment requires absolute perfection. They are building the very first extraterrestrial Wi-Fi network. Without it, the heavy machinery is completely blind, deaf, and paralyzed. Space colonization is a brutal war of attrition fought with heavy steel, rugged mechanical drivetrains, and hardwired municipal utilities. As we project this timeline from 2029 through 2032, the procurement curve takes a vertical spike. 6 heavy launches in 2029 to clear the footprint, 7 heavy launches a year through 2032, dropping cell towers, atomic grids, and armored rovers. This grid is the exact technical threshold that shifts lunar operations from a high-risk government science project to a multi-user commercial landscape. Factions that successfully integrate their hardware into these wireless and data standards will permanently dominate the transit corridors of the South Pole. But this raises a critical, unsettling question. Does giving private actors a monopoly on extraterrestrial commercial transport and foundational utilities like cell towers and power grids represent a brilliant method to de-risk NASA's operations, or does it permanently surrender state sovereignty and control over the primary economic infrastructure of deep space? We are going to further discuss this in our next video. Until then, stay analytical and stay curious.